All right, welcome, ladies and gentlemen, to section 2.7. We're going to be dealing with inequalities involving two variables. So we're going to be looking at linear and absolute value inequalities. We're going to look at what types of graphs they will look like. We're going to look at what kind of lines we need to draw and that sort of idea. We're going to start off with just a refresher from our previous classes, maybe an Algebra 1 class. We're going to look at solving simple linear inequalities, or not linear, but simple inequalities, single variable. If I was to ask you to solve and graph, this particular one requires no solving, but we can graph inequalities on number lines. And on this number line, we need to involve the number 3. And as you recall, we want to start at 3. The x is greater than or equal to 3 means all of the numbers that are bigger than 3. And we need to include the number 3 because the equal sign. So in order to show starting at 3, we need to put a dot because it's equal than or equal to. We're going to fill in that dot. Now we're going to shade all of the numbers that make a true statement in this inequality. So like the number 4. 4 is bigger than or equal to 3. 5, 6, all of these numbers that are in this arrow region are answers to this inequality. So what we can do is then start looking at other simple inequalities. This one being x plus 7 is less than 9. We need to subtract 7. What we can say is x is less than 2. All right, well, if I want to show what that looks like on a number line, again, I start my number line. I need to involve the number 2. We need to go less than, so we're looking at the numbers on the left of 2. Because it's strictly less than and not equal to, we use an open dot. And again, we shade everything to the left, which is all of the numbers less than 2. All right, and all of these are kind of the same idea here. If I was to say 2x plus 3 is greater than 4, I would subtract 3 from both sides. I would get 2x is greater than 1. Divide by 2, I'd say x is greater than 1 half. And I would go back to my number line, and I would graph at 1 half. I would use an open dot because the equal or no equal to, and I want to go greater than, so I go off to the right. Now, there are some rules when you solve inequalities of this type. One of those rules comes in a statement like this. If we were to try and solve this inequality, we would subtract 4 from both sides, and we'd get minus x is less than or equal to negative 13, because negative 9 minus 4 is negative 13. One of your rules that you had to remember is that if you divide by a negative number or multiply both sides by a negative number, what happens is you must flip the inequality sign. So rather than having less than, this now becomes greater than or equal to positive 13. Oops. And we would graph this again as starting at 13, putting a closed dot because it's equal to, and going to the right. All right, so that is one rule you have to remember for inequalities when you're solving them. You must, if you divide or multiply both sides by a negative number, you must flip the inequality. All right. Now, that was just a refresher. Let's take a look at what we want to do in today's lesson. A linear inequality is an inequality with two variables, so we're looking at x and y, whose graph is a region of the coordinate plane that is bounded by a line. So what is that going to look like? Oops. That is going to look like something like this. We have this, which is our axes. This is our coordinate plane. We're then going to have some form of a line, and on one side of that line is going to be a shaded region. So let's call it, let's go with the red here. Let's call it this section right here. And everything on this side of the line would make the inequality true. So let's go through the how-to. And this goes for absolute value inequalities as well, not just linear. It goes for all types of inequalities, actually. First, let's go through a how-to. So first, we're going to graph the line, whether it be a straight line when it's linear or a V-shaped line like an absolute value. When you graph the line, you have two different versions of lines, just like we had on regular inequalities, where you had either an open dot or a closed dot. The closed dot would be the version of our solid line, where it has the equal to. And the open dot is like our dashed line if you have just the less than or the greater than symbol. After you've graphed the line, you need to test a point on one side of the line, meaning if I was to choose some coordinate out here, let's say I chose this one, and I plugged that coordinate into my inequality, and if it made a true statement, then I need to shade everything that's on the same side of that line. And if it's a false statement, then I shade the other side. So in this case, if I tested this point, this black point right here, and it came out true, notice I shaded the same side of the line. All right, so that's the how-to. Let's look at what that's going to look like as actual work. So here we have the linear function, or linear inequality, y is less than 3x minus 1. So what I need to do is set up some axes. And on this set of axes, I need to put on -1 because my y-intercept, by the way, this is my y-intercept, the -1, and my slope is 3. So here at -1, I need to go up 3 and right 1, and eventually down 3 and left 1. So here's -4, and here's 1, 2, 3. All right, so to draw this line, I need to say, okay, my y-intercept is -1. I'm going to go up 3 and right 1. I forgot to put the x-axis here. All right. Then I need to go up 3, right 1, and I'm going to go down 3 and left 1 as well. And because this is a less than, not equal to, this gets a dashed line. And I don't have a ruler, so I'm doing the best I can here. You should all have rulers. Then, so that's the first part of our how-to. The second part of our how-to was to then test a point. So I like to choose a very, very simple point. And the very simple point to choose is the point 0, 0. So if I started with the point 0, 0, I need to test to see if that's true or false in this statement. So if and note that the line does not go through 0, 0. You cannot choose a point that is on the line. So here I'm going to plug in 0 for y and 0 for x, if I can do this right. And I need to see, is this true? So I have 0 is less than 0 minus 1. So 0 less than -1. So I ask myself, is 0 less than -1? I know that is false. And since the origin, the 0, 0, is on the left side of the line, and it's false, I need to shade the right side of the line. And there we have our graph. Every coordinate that is in this shaded region is a solution. So if I was to choose the point 2, -2 down here, this will be a true statement up here. We can test that. If I use the point 2, -2, that would be y is -2, and x is, let's fix that there, x is 2, and I would say -2 is less than 6 minus 1, which is 5, and that is true, and that is false. So the left side is false, the right side is true. And you can test any one of the points that are in this inequality, or in this shaded region, and it would always come out true. All right, let's try another one. We have y is greater than or equal to 1/2 x plus 2. So again, I'm going to set up my axes because there's nothing that I have to do any extra setup here. I need to create some numbers here. All right, and then I'm going to graph my line. So I have a y-intercept of 2 and a slope of 1/2. So I'm going to go up 1, right 2, and I'm going to go down 1, left 2. This is a greater than or equal to, so this one gets a solid line. That solid line now has kind of a top and a bottom half of the graph, so I need to test a point. Well, this line does not go through the origin, so I'm going to test the point 0, 0. So here's the 0, 0. I'm going to plug in 0 for y. I'm going to plug in 0 for x. And I get 0 is greater than or equal to 0 plus 2, which is 2. That is a false statement. And since the 0, 0 is down here, I need to shade above my line. And that's the shaded region. That's the graph of this inequality. And you can do any type of shading you want as long as you shade just the upper part of this graph. All right, let's keep going here. Got a couple examples. I want to make sure we understand what we're doing here. This is a good freshen up on how to graph linear function as well as absolute value functions, and then throwing in the absolute values. All right, so last one for the linear before we look at a couple examples of the absolute value. I have one in standard form for a very good reason. When I set up my axes, if an equation is in standard form, one of the easiest ways to graph it is to find the intercepts. So I need to plug in x equals 0 to find y, and I need to plug in y equals 0 to solve for x, finding my two intercepts. So if I plugged in x equals 0 here, this would go away, and I would get 3y and 6, which means y is equal to 2. Likewise, I plug in y for 0, or 0 for y, and I get 2x is equal to 6, divide by 2, and I get 3. So I can say I have, let's see, blue. So I need to go up 2 on the y, and I need to go out 3 on the x. And what this now lets me do is plug in the point 0, 2, and use the point 30. This has an equal than or equal to sign, and therefore I get to use a solid line. Not doing too bad with this solid line thing here. And again, we're going to use the point 0, because this line does not go through the origin. So I'm going to use the point 0. So I'm going to plug in the point 0 for x. I'm going to plug in the point 0 for y. And I get 0 plus 0, which is just 0. And that is actually a true statement. And since that is a true statement, that means I'm going to shade everything where the 0, 0 is. And that is the graph of this inequality. All right, so enough with linear. Let's take a look at the absolute value inequality. So good refresher on graphing absolute values here. If you remember from the last few lessons here, we can find the vertex rather simply. Let's get axes here first. The vertex is going to be whatever makes the inside 0. So this got shifted 4 units to the right and 5 units up. There's my vertex, so I'm going to go out to the point 4, 5. 2, 3, 4, and 1, 2, 3, 4, 5. So if I go to the point 4, 5, and then I can use the slope of 1 in this case on both sides. This is less than or equal to, so this does get a solid line. Now, note the difference between what we just did and what this one is. This one is a V shape, so we can either shade inside the V or outside the V. But the process is still the same. I'm going to use the point 0, 0 because it's a really easy point to use, and my graph doesn't go through the point 0, 0. So if I plug in 0 for y, 0 for x, I can then simplify here. I get 0 is less than or equal to the absolute value of 0 minus 4. 0 minus 4 is negative 4. The absolute value of that is 4 plus 5 is 9. So I get 0 is less than or equal to 9, and that's a true statement, which means we need to shade everything on the outside of the absolute value graph. Now, I know some of you guys are going to get all fancy with your shading and all that, and the great, and the shading of your graph. But this right here is the graph of this inequality. Fanciness is not necessary when you're shading a graph. The most important piece is to find out where the shaded region is and to also graph the inequality itself. All right, let's try one more right here, and then I will set you loose. This one is a good one because it requires you to get y by itself first. So what we're going to do here is we are going to subtract 3, and we're going to subtract 3. When I get rid of that 3, I get a negative y is greater than x plus 1 minus 3. And we have to get rid of the negative, so we have to divide by negative 1. And we have to divide by negative 1 here. And we have to divide by negative 1 here. All right, so when we divide the y by negative 1, we get y. Remember, when we divide both sides by a negative, we have to flip the inequality. The absolute value becomes negative on the outside. And then minus 3 becomes plus 3. So we can then again look at the vertex. This got shifted 1 unit to the left and 3 units up. So we look at this, we look at this, we come in here and we say, let's find some numbers here. So we went 1 unit left and 3 units up. And we're going to plot that dot. 1 unit to the left, 3 units up. This one is a negative absolute value, and therefore it's going to go downwards. So we're going to go down 1 left 1, and we're going to go down 1 right 1. And this does not have the equal sign, so this one is going to be a simple dashed line. And there again, the 0, 0 coordinate is not part of my line. So we're going to test this, and we are going to plug that in. 0 for y. And, oh, actually, we're not supposed to do it there. We have to do it the original equation, or original statement. 3 minus 0 greater than 0 plus 1. 3 minus 0 is 3, greater than absolute value of 0 plus 1, which is just 1. Looky there, we got another true statement. 3 is bigger than 1, and since the 0, 0 is inside the v, we get to shade everything on the inside of the absolute value. There you have it. That is going to be enough to get us through. You can always find more examples online somewhere if you'd like to find more examples. This is our last lesson for this particular chapter. So let's make sure we know what we're doing, and hope you learned a little bit today. I will see you guys later.